Okay, Bismillah ar-Rahman ar-Rahim. Inshallah, we'll continue. We did up to question 30. So now we'll continue doing the rest. We have, I think, many problems. Around, I think, 20 more problems. 31. Limit. X goes to infinity. X plus 1 over x squared plus 1 cubed. Okay. You can think of it, this is degree 1, this is degree 2 over 3, so it goes either to infinity or minus infinity. We need to double check. So what I will do, you can think of it as what? X plus 1 over cube root x squared plus 1. I'll do the same trick. So I will do this limit, x goes to infinity, x times 1 plus 1 over x over here, cube root. I take x squared common factor. I have what? 1 plus 1 over x squared. So that will give me what? X goes to infinity. X 1 plus 1 over x to the power 2 over 3 times this. So as a limit, this goes to 0, this goes to 0, and you have what? Limit, or before that, I'll do this next step. That will be what? X to the power 1 over 3. This over this. Times 1 plus 1 over x. Or square root 1 plus 1 over x squared. Yes. This goes to 0, this goes to 0, this goes to infinity. So I have infinity times 1 over 1, which is infinity. 32. We have what? Limit. X goes to minus infinity to x over x to the power 6 minus 1 to the power 1 over 3. Just cube root. This kind of think of it as same degree, huh? But let me do it in details. Since this 6 over 3, no, it's not same degree. This is degree 1 over degree 2. So it will be 0, but let us do it in details. This is 2x cube root x to the power 6 minus 1. Same trick. I'll do limit. X goes to minus infinity. 2x. Here I will take x to the power 6 common factor. 1 minus 1 over x to the power 6. And that will be limit. X goes to minus infinity. 2x. Cube root of x to the power 6. It will be x squared. Actually, no need for the absolute value in this time. Huh? We know that the nth root, x to the power n, this is x if n is odd, huh? Which is this case. That will be x squared. 1 minus 1 over x to the power 6. This will be x. So you have 2 over infinity, 2 over minus infinity, or infinity, who cares? That will be 0. 33. Limit. S goes to infinity. 1 over 2x plus sine x. I think it's very clear. We did something similar for cosine, which is we do it by the squeeze theorem. Sine x between minus 1 and 1. 2x minus 1, you add 2x. Spherical. When you do a spherical, I think it should be, yeah. It should be this will go this side and this will go this side. Huh? Yeah, I think I forget to do it. It will not make a difference in the calculation, but that's what will happen. This will go to 0. This will go to 0. So this goes to 0 by sandwich theorem or squeeze theorem. So this limit is 0. Don't forget, this is I It means this will go this side and this goes this side when you do the reciprocal. I forget to do it with the cosine. I was thinking about the last answer. 34, limit is goes to infinity, cosine 1 over x. That will be 1 over infinity, 0. Cosine 0 is 1. So this is 1. Direct. 35, limit as this goes to infinity, sine 2x over x. You have what? You have a value over infinity. So it should go to 0. So you need the squeeze theorem to do this. This is it to go to 0. Why? Because sine 2x is between -1 and 1. You divide by x. X is positive, since I'm dealing with minus goes to infinity. This goes to 0. This goes to 0 as x goes to infinity. So this for sure goes to 0 by sandwich theorem. So this is 0. 36. What is the limit? It goes to infinity. X minus cosine x over x. By the way, if we substitute, you have infinity minus a number, which is infinity over infinity. So undetermined. Huh? But most of the things we did before is the same idea. You have 0 over 0 or infinity. You need to think of it. This one I can simplify it as what? X over x minus cosine x over x. This one I can do by squeeze theorem, and this is 1. So this will be limit x goes to infinity, 1 minus cosine x over x. I know this will be 0. How? Since cosine x is between -1 and 1, provided x is positive, that will not change the sign. As it goes to infinity, it goes to 0, this goes to 0, that means it goes to 0 by sandwich theorem. So I have 1 minus 0, which is 1. 37. I'm doing most of these problems, by the way. As I said, it will be more than the what is written, the suggested problems. So this one goes to 0, since e is minus infinity, which is 0. So 2 minus 5 times 0, which is 2. 38. Limit is goes to infinity. 8 over 4 minus 10 to the power minus x over 2. Same idea. You know, e or any number is the same idea. So if you plug infinity here, you have 10 to the power minus infinity, which is 0. This is 0. This goes to 0. So you have 8 over 4 minus 0, which is 2. 39. Limit as this goes to infinity. Look with the base 10. 1 plus 10 to the power minus x. This goes to what? 10 to the power minus infinity, which is 0. So I have log with the base 10, 1 plus 0. And that will be 0, which is log 1. 40. I think these are the problems, huh? This is what I'm doing. This is what we did before. Oh, these are the problem in the next group, which is we did this, we did this, we did this. I'll do the remaining 3 or 4. Okay. 40. Limit. This goes to infinity. 5 over 2 plus ln x squared plus 1 over x squared. How to do this? 5 over 2 plus ln x squared plus 1, is it? Let me check how they wrote it. It's ln. The ln is no. Yeah, this is not the right one. This is ln x squared plus 1 over x squared. خلاص. So take the limit inside. This will be 5 over 2. So just to be concerned, we are concerned that this limit ln x squared plus 1 over x squared. I take the limit inside. That will be ln of the limit. Which is 1. So I have ln 1, which is 0. So this is 0. So this problem will be what? 5 over 2 plus 0, which is 5 over 2. 41. Notice I'm doing almost all the problems. Limit t goes to infinity. 8t is minus 1 minus arctan of t. This is 8 over infinity, which is 0. So that will be 0. And this is pi over 2. So the answer is minus 2. Quickly. 42, which is the last one in that group. Limit as this goes to infinity. Arc secant of u plus 1. You need to check as this goes to infinity. What will be arc secant of infinity? It will be arc secant of infinity. So I need the cosine to be 0. Cosine will be 0. That will be pi over 2. So it will be pi over 2. This goes to infinity, arc secant of infinity, which is pi over 2. Okay. Now I move to the next group problem, which is this one. Finding horizontal asymptotes. So I need to check right and left. 42, 43. I need to check horizontal asymptote for this function. Absolute value of x over x plus 1. How to do that? Check limit, x goes to infinity. This one will be positive. That will be x over x plus 1, and that is 1. X goes to minus infinity. That will be minus x over x plus 1, so the limit is minus 1. So I have two horizontal asymptotes, y equal 1, y equal minus 1. These are the horizontal asymptotes. Next one, 44. Y equal 5 over 3 plus 6. E is minus 4x. This is, if you do limit, x goes to infinity. This is will be 0. A is minus infinity, which is 0. So it will be 5 over 3 plus 6 times 0, which is 5 over 3. Limit x goes to minus infinity, or the same function. Now this one will be e is minus infinity, e to the power infinity, which is infinity. So I have 5 over 3 plus 6 times infinity, which is 5 over infinity, which is 0. So I have two horizontal asymptotes, y equal 5 over 3 and y equal 0. These are the horizontal asymptotes. Next one, 45. F of x equals 3x over square root x squared plus 2. So check limit goes to infinity. Actually, what you need to do, you need to do this trick, taking a common factor. So this is will be 3x. Maybe I can do it for the function. Okay. And that will be what? 3x over absolute value of x, 1 plus 2 over x squared. Now when you deal with the limit, as it goes to infinity, I have what? 3x over x square root 1 plus 2 over x squared. This is cancelled, so you're having 3. Limit x goes to minus infinity for the same function. Yeah, maybe this way is better. This will not be x. So as x goes to minus infinity, these things will be minus x. There's a minus sign. So cancelled. This is same thing, goes to 0, goes to 0. So I have here, in this case, minus 3. So I have two horizontal asymptotes, y equal 3 and y equal minus 3. These are the horizontal asymptotes. 46. This is the function. Square root 9x squared minus 2. Correct? Oops. Over 2x plus 1. I simplify the function. Take x squared common factor. You have 9 minus 2 over x squared over x. Here I do what? 2 plus 1 over x. So that will be what? Absolute value of x. X. Yeah. Now check the limit as it goes to infinity. So that will be x. X 9 minus 2 over x squared over x 2 plus 1 over x. Cancelled. You have 3 over. Limit as it goes to minus infinity. This will be minus x. 9 minus 2 over x squared over x 2 plus 1 over x. X cancelled with x. You get minus 3 over 2 in this case. Yeah. This is 46. What do you think will do this group of problems? Now we'll do 47 and 48, where I need to find what they want. Specific limit. X goes to infinity, actually. I'll do 47. 48 is the same. So 47, same idea, I mean. 47, limit as it goes to infinity. X sine 1 over x. What you will do, let t equal 1 over x. So this will be limit if the equal 1 over x, so x equal 1 over t. So that will be limit 1 over t sine t. As this goes to infinity, t goes to 0 from right. So that will be sine t over t as t goes to 0, which is 1. The same thing for the next problem. Now we did this. Now this is the limit with the square root, where I need to do some rationalization. So let us do it. This is question 50. I'll do some of them, not all of them. 50. Now limit x goes to infinity of what? X minus square root x squared plus x. If you apply the limit, you have infinity minus infinity. So rationalize. I think we did this idea many times. That will be limit x goes to infinity. x square minus x square minus x, and multiply minus for both. Huh? So that will lead us to, this is cancelled, taking a common factor, this is minus x, I take a common factor here, take x square, 1 plus 1 over x. So that will be limit, x goes to infinity. The same idea, square root of x square, which is absolute value of x. So it's minus x, x plus absolute value of x, square root 1 plus 1 over x. Since this goes to infinity, this goes to x. So I can take this limit, still limit, minus x. I take x common factor. I have 1 plus square root 1 plus 1 over x. Cancelled. You get what? Minus 1 over half, minus 1 over 2. This is 1, this goes to 0. So 1 plus 1, 2. So that's it. 51. Limit as goes to minus infinity of 3x plus square root minus a square plus x. Is it? Minus x. You apply it, you have here infinity, but you have here minus infinity. So you cannot conclude anything. You need to divide by 1, rationalize it. That will be what? Limit x goes to minus infinity, 9x squared minus 9x squared plus x. Multiply minus by all of this, huh? Okay. Down I have what? 3x. Let me do the common factor here. So I have x squared, 9 minus 1 over x. Well, the same idea, I have square root of x squared absolute value of x. That will be limit, x goes to minus infinity. This is cancelled, x over 3x minus absolute value of x, square root 9 minus 1 over x. Notice this is minus x since I'm going to minus infinity. So this will be plus. So this is limit x goes to minus infinity. X, I take x common factor. I have 3 minus this plus. It will be minus times minus, so that will be plus, and that what will help. That what will fix it. So I have x cancelled with x. So I have 1 over 3 plus 3, which is 1 over 6. Okay. And we did all of these problems, some of them, 50 and 51. Now we'll do these problems. He asked here about doing it by the table, by the graphs, and he wanted to do it analytically. Finally, and the limit analytically, calculations. So let me do it by the calculation. What he want? Yeah. Graphic analytical analysis. There is no, he's taking it as x goes to infinity in both cases. Huh? In all cases, he's going to bigger number. He's taking x bigger number. So he want in exercises use a graphing utility to complete the table and estimate the limit as it approaches infinity. So he want as it approaches infinity of these functions. What will be the value as it's approaching infinity of these functions? I have the first one, 53, f of x, x minus x times x minus 1. I'll check when this goes to infinity, what will happen. If you apply, I want to check the limit as it goes to infinity of x minus x squared minus x. This is what I'm doing. So apply infinity, You have infinity minus infinity, which is a problem. Here we have infinity minus infinity. So it means we need to rationalize it. X plus that will be limit. X goes to infinity. X squared minus x squared plus x. Here I take a common factor. X squared. I have 1 minus 1 over x. That will be the same thing, absolute value. And it will be x, since x goes to infinity. Just to save time, that will be x plus, actually it's an absolute value. That's just, this is x, so I take x as common factor. Take x common factor, you have 1 plus square root 1 minus 1 over x. Cancelled, you have half. This is 53. 54 f of x equal x sine 1 over 2x. They want the limit as it goes to infinity of this function. We'll do the same trick, which is by let t equal 1 over 2x. That means x equal 1 over 2t. So this is will be limit 1 over 2t. Yeah, x to be 1 over 2t sine t. T goes to infinity, x goes to infinity, t goes to 0 from right. So we have what? This limit is 1 as t goes to 0, so you have half. Okay. 54. We have f of x equal x squared minus x square root x times my x square x, here wrote it back this way. Yeah, correct. Yeah, this one. X times similar to this one, but he make it x square and he put this and that. Okay. That will be what? X square minus x square root x square minus x, not one. So if we apply the limit, I want to check limit x goes to infinity of this function. By the limit you have, here we have infinity minus infinity. So it means there's a problem. Rationalize it. So that will be limit x goes to infinity, x to the power 4, correct, minus x squared times x squared minus x over this. Here I can take x squared common factor. I have 1 minus over x. So that limit will be equal. Let me write it here. Limit is goes to infinity. Here we have what? In this, we have x to the power 4 minus x to the power 4 plus x cubed. So you have x cubed. This is cancelled. Huh? Here I have what? X squared plus x square root of x squared, which is absolute value of x again. Square root 1 minus 1 over x. So this is will be x. It means I can take x squared as a common factor, and the remaining is what? Is 1 plus square root 1 minus 1 over x. That will give me what? Limit x goes to infinity. This is cancelled. This is cancelled. X for 1 plus 1 plus 1 minus 1 over x. As it goes to infinity, this is 0. So I have infinity over 2, which is infinity. Now 56. f of x plus 1 over x square root of x. This is like to what? X plus 1 over x to the power 3 over 2. So if you divide by 3 over x to the power 3 over 2, you get everything, which is degree of the numerator is less than degree of the denominator. I'm expecting getting 0. But I can do it by divide by x to the power 3 over 2. Numerator and denominator. Usually divide by the highest power in the denominator. That will give me what? Limit s goes to infinity. This will be 1 over x to the power half plus 1 over x to the power 3 over 2 over 1. As goes to infinity, it will be 1 over infinity, 0, 0. So it will be 0 plus 0 over 1, which is 0. Yeah, I think those are the problems which I did. Yeah. The rest is just all the problems. Now we can avoid, no need for this. Yeah, they're just they're giving you functions and then asking about the behavior, but he make it like about the problems. I will do this. They're true false. There is no true false. This we did in the class for the polynomial, for the rational function. Huh? This is the limit. Huh? The 3 cases. Yeah, I think I'll stop here. Or yeah, this will be the end of section 4.5. Thank you.